Assalamualaikum warahmatullahi wabarakatuh. Good morning for all of the audience. Today I would like to do my assignment for English subject, but first of all let me introduce myself. My name is Dina Amelia. I am from Civil Engineering. My NPM is 197011-032 and I'm from class A. So I have two topics here. The first one is about geological classification and the second one is about evaluation of aggregate sources. So let's begin with part 1, which is geological classification. All natural aggregates result from the breakdown of large rock masses. Geologists classify rocks into three basic types, which are igneous, sedimentary, and metamorphic. Volcanic action produces igneous rocks by hardening or crystallizing molten material, which is magma. The magma cools either at the Earth's surface, when it is exposed to air or water, or within the crust of the Earth. Cooling at the surface produces extrusive igneous rocks, while cooling underground produces intrusive igneous rocks. In general, the extrusive rocks cool much more rapidly than the intrusive rocks. Therefore, we would expect extrusive igneous rocks to have a fine grain size and potentially to include air voids and other inclusions. Intrusive igneous rocks have larger grain sizes and fewer flows. Igneous rocks are classified based on grain size and composition. Coarse grains are larger than 2 mm and fine grains are less than 0.2 mm. Classification based on composition is a function of silica content, specific gravity, color, and the presence of free quartz. Sedimentary rocks coalesce from deposits of disintegrated existing rocks or inorganic remains of marine animals. Wind, water, glaciers, or direct chemical precipitation transport and deposit layers of material that become sedimentary rocks, resulting in a stratified structure. Natural cementing binds the particles together. Classification is based on predominant mineral present. For example, like calcareous, like limestone, chalk, and others, and then siliceous, like chert, sandstone, and others, and the last one is argillaceous, for example, like shale. Metamorphic rocks form from igneous or sedimentary rocks that are drawn back into the Earth's crust and exposed to heat and pressure, reforming the grain structure. Metamorphic rocks generally have a crystalline structure with grain sizes ranging from fine to coarse. All three classes of rock are used successfully in civil engineering applications. The suitability of aggregates from a given source must be evaluated by a combination of tests to check physical, chemical, and mechanical properties, and must be supplemented by mineralogical examination. The best possible prediction of aggregate suitability for a given application is that based on historical performance in similar design. The last topic is about evaluation of aggregate sources. So, civil engineers select aggregates for their ability to meet specific project requirements rather than their geologic history. The physical and chemical properties of the rock determine the acceptability of the aggregate source for a construction project. These characteristics vary within a quarry or gravel pit, making it necessary to sample and test the materials continually as the aggregates are being produced. Due to the quantity of aggregates required for a typical civil engineering application, the cost and availability of the aggregates are important when selecting an aggregate source. Frequently, one of the primary challenges facing the materials engineer on the project is how to use the local available material in the most cost-effective manner. Potential aggregate sources are usually evaluated for quality of the larger pieces, the nature and amount of fine material, and the gradation of the aggregate. The extent and quality of rock in the quarry is usually investigated by drilling cores and performing trial blasts, or shots to evaluate how the rock breaks, and by crushing some materials in the laboratory to evaluate grading, particle shape, shallowness, durability, and the amount of fine material. Cores are examined petrographically for general quality, suitability for various uses, and amount of deleterious materials. Potential sand and gravel pits are evaluated by collecting samples and performing shift analysis tasks. The amount of large gravel and cobble sizes determines the need for crushing, while the amount of the fine material determines the need for washing. Petrographic examinations evaluate the nature of aggregate particles and the amount of deleterious material. Price and availability are universal criteria that apply to all uses of aggregates. However, the required aggregate characteristics depend on how they will be used in the structure. This is the end of my presentation. Sorry if there is any mistakes and I hope you get the knowledge. Thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.